Happy to have everyone in the class. Although I guess the class is not yet full, we are seeing some people to come. And why my camera is switching off, just like that. Okay. So start with sharing our slide so we can proceed from there. Okay, so we will continue from where we stopped for the last class. But as usual, we are always starting our classes with hearing questions from previous class. And as we know, it literally helps us to, understand better if there are anything we did not exactly get from the previous class. So I'll open the door for questions to come in. You can use the raise hand button to ask questions based on what we discussed from last class. If there's any question on your end. Are there any questions? Okay. I will take the silence as no questions. The next thing we usually do is to basically review what we've spoken about. And this time, I would definitely like someone, as usual, to give us more like an overview of what we've discussed from last class. The reason why I'm doing this is so it can stick more. Whoever talks about it, that's the good thing. If you talk your own or our own personal brain memory to remember everything that is being taught. So feel free to use the raise button to, if you are willing to speak from last class, feel free. Go over what we discussed. Or should I call names if you are shy? I'm seeing Keisha here. Would Keisha tell us anything from what she gained from last class? Okay, we have Silvanus, but let's ask Keisha. Silvanus is very active in answering questions in class, and I really appreciate that. But let's start with Keisha first. You can unmute and speak. Keisha, anything from last class? How about Bilwa? Did you remember anything from last class? Or is it that you did not understand what we had explained from last class? I want us to be interactive. We gained, yes, you speak up and then we talk about what you have gained. And if you did not exactly understand it, we can go back to it and talk about it. We spent 6 minutes into the lecture, basically just to, grasp what we have discussed from last class so we can be sure that, yes, it has been understood properly. And then we can move forward. So, Belua, can you unmute and speak? How about Ben? Is there anything you gained from last class? Or nobody remembers anything from last class?
Hello, how you?
Hi.
Yes, I don't understand much, but I can say what I've heard. I'm still gonna study some more of what we discussed yesterday. But in terms of understanding, I'm not there yet.
Okay. Okay. So you,
We did the introduction to Stellar Stack and running a Stellar core node, its points and additions, and Horizon API overview, its points and additionals, and also we spoke about RPC overview and SDK overview, SDKS overview, and developing with SDKS, and we spoke also about lumens.
thank you very much. Thank you very much. You've spoken from what we discussed last class. Thank you, Ben. Someone else raised his hand a minute ago. Yes, you can unmute and speak, please.
Hello everyone, here is Ayemu. So from last class, we saw how RPC and also Suburban smart contract interacts within the Stellar network. We mentioned, by the way, that the Stellar native currency is Lumen. And sometimes people make some confusions when it comes to Ethereum. Just funny mention it. As native token for Ethereum is also Ether. We saw that we use XLM sometimes for rent, and particularly mentioned that rent is most used for storage. And when it comes to storage, we need to understand that we can have temporary and permanent storage. And at this level, temporary can be quickly archaic when it comes to smart contract reading. And Horizons is more designed like an API. And RPC is more like an endpoint used for the smart contract. And when we are going to progress and develop, RPC will be more the one that we will use for live interactions. And for the last point I mentioned also, there are so many opportunities when it comes to suburban smart contract learning, because we can be both smart contract suburban or suburban auditor.
Thank you very much. Thank you so much. I really, really appreciate you because you've literally given an overview of every single thing we spoke about. So thank you very much. And keep it up, please. Keep it up, please. So I'd like to hear from you, Joycey. Your hands are raised up.
Good evening, everyone.
Good evening.
Yes, I also want to add that we also discussed why we should run a Stellar core node. And we said we can do it to get incentives and also to increase network decentralization, to enhance security, and also there's potential for influencing decision-making in the network. And we say that if you are running a Stellar core node, you must do it with your own resources and that you must always be online.
Excellent, excellent point. Excellent. Thank you. Thank you. That is another thing we spoke about. Thank you so much. Thank you so much. I'm actually very, very happy and glad that yes, I got response from Ben, Joycey, and Ayemo. Thank you so much for the responses. And these responses literally gave an overview. Just want to say something. Please go ahead and unmute your mic. Yes, you can unmute your mic, please.
Okay, thanks. Sorry, I didn't, yesterday I couldn't catch the entire part, but I was also interested in terms of the nodes, running your own Stellar nodes, because I think, we'll need to get to like a practical understanding of how the network really operates. I know right now we're still, in the theoretical phase, sort of what is a smart contract and Rust, and it's going to get very, very technical, but we should also get to the practical application side of things. Like, how does actually blockchain work in the real world? Like with I know Stella has some things with MoneyGram and cross-border forex exchanges and things like that. And MoneyGram is like a very big payment processor. It's Africa-wide. They're like one of the biggest in the world. So I think once we get to see how to set up practically, how does it work? What type of data center do you need? What type of connection speeds? What problem does it actually solve? Then I think people will start to actually, learn that even with contracting nowadays, you can outsource that part if that's not your core competency, but you can still learn how everything works. Like there's a lot of aspects. I mean, one of the earlier classmates mentioned something about smart contract auditor, but that's one part of the industry. There's also like, data centers and renewable energy. If you're good with that type of stuff, you can also get involved with running a Stellar node because they're looking for better energy use. And we know in Africa, there's a lot of renewable energy projects going on. So I think once this class gets to that part about connect the dots, about technically how do you get it to run and make it work, and also example in the real world, how does it actually work? And then I think, that will really be a big benefit to people and they'll understand it much, much better.
Thank you very much, Tess. Thank you very much. To summarize what you've just made mention of, you wanted to see practical application as to how the node is being run. Okay, so I don't know if you were in previous classes from the beginning of this lecture that started from last week. I spoke about what our main focus would be. Now, there are different angles to being to the blockchain space entirely. Now, these different angles could include smart contract development, the protocol layer itself, that's even building the Stellar core itself. It could also talk about the auditor aspect of things, or even talk about entrepreneurs when it comes to running of nodes. Now, there are different aspects to this, and from my previous sorry, my system just tripped off. I'm trying to understand why it tripped off. I'm very sorry about that. Okay, going back to what Tess made mention of, like I said, there are different aspects to the blockchain space entirely, and this is what I spoke about. But all of these aspects we cannot dive into completely. Why? This is because this course is streamlined into turning those who have been blockchain developers from other chains into Stellar blockchain developers. In what sense? They're able to learn how to write smart contracts. And so this course will involve understanding the fundamentals of blockchain and teaching Rust from the underlying point, that's the basics, the foundation, up to building smart contracts. And this is also why it is recommended for those with zero knowledge on it. Now, why this course would definitely be talking about other parts or to which you can apply yourself as a blockchain, Stellar blockchain developer, or a different part entirely in the Stellar ecosystem. We are streamlined to having the participant of this course go through understanding how to write the Rust programming language and how to write Soroban smart contracts, deploy it, interact with it, and on like that. So we would not be showing how to run a node. From last class, I made it clear that if you want to participate and run a node, you can basically go online to the Stellar documentation and then go through the process. And in fact, that's one of the things I actually want to do in today's class, going through the documentation. So some of the things that I'll be explaining from today's class would not come from the slide, but instead it would come directly from the Stellar documentation. So does that answer your question, or does that sum up your comments, Tess? Okay, great. So thank you very much, all participants who was able to give answer to what we have learned from our previous classes, where we spoke about the Horizon API, we spoke about using it, we spoke about the RPC, we then spoke about SDKs in general, then developing with SDKs, we spoke about the fact that you could develop it in different languages. And the class started talking about lumens. Was that a mistake, Junior?
Yeah, it was a mistake. I'm fine.
Okay. So the class ended by talking about lumens. Due to our time, we were unable to complete the slide on lumens. So we started by explaining that lumen is literally the native currency on the Stellar network. And I compared this to the Ethereum chain, where I explained that on the Ethereum chain, the native network there is Ether. And then other tokens you have, other currencies you have on the network are just ERC20 tokens now on the Ethereum network. Now, you cannot compare the ERC20 tokens to the native token, which is Ether there. The same thing applies to Stellar. On Stellar, Lumen is the native currency. Now, other tokens like USDC, these are not inbuilt into the Stellar network. Rather, they are smart contracts on the Stellar network. We started speaking about what these lumens can be used for, and we spoke about the fact that we use it for transaction fees, and these transaction fees, we are going to go deeper into it in today's class. We're going to talk about how this transaction fee is being calculated. In fact, we are going to see the code base that actually, speaks about this transaction fee and how it is being done. We're going to look at the code base. Fine, we won't be doing any practical in this class. We haven't gotten to the point where we'll be practicalizing and writing code. We haven't gotten there. But we'll just look at the code through the documentation as to how these fees are being calculated based on what type of transaction is being sent to the chain. We're also going to look at the rent. We see this literally from the official Stellar documentation on how the rent fees is being done, because you have to pay when you are renting, at least the storage. And from what someone made mention of while explaining what I taught from last class, he spoke about how the lumens are used for paying the rent. Also, Talking about the native currency, it is built into the Stellar network. What does building it into the Stellar network means? This means that the XLM is not a smart contract. Rather, it is built into the core of the Stellar chain itself. So it's not just a smart contract that is deployed like USDC and other tokens that can be deployed on top of what? On top of the Stellar chain. No issuer or trust line required. So unlike other assets on Stellar, Lumen does not need an issuer or trust line. It's used for various network fees. This will be spoken about transaction fees, account creation, and other network operations. We're going to talk about network operations in one class. Look forward to that. Stellar has so many network operations, actually, and we are going to look at some of these network operations. And obviously, we cannot cover all of the network operations because they are actually quite much. But look forward to that class where we'll be talking about the operations on Stellar. Some additional details. We have the supply dynamics explaining of how the XLM's fixed supply and the deflation mechanism is being done. What does this mean? This is just talking about the tokenomics behind the supply of the XLM. So that's literally what the supply dynamics is all about. Looking at the market role, the overview of XLM's role in the broader cryptocurrency market and its use case. What are we trying to say here? The truth is, while you can, use other means, as Tess made mention of, Stellar is big on MoneyGrams as it allows you to, in fact, that's one of the major tools for you to do the cross-border payment using the MoneyGram with Stellar. But on the underlying surface, the Lumen itself can serve as a token because you don't need to be in a particular geographical environment to be able to acquire the Lumen's token. So it could actually be a token that is actually used to pay for different things because it has financial backings. So in the broader cryptocurrency market, if you think about Lumen, as an employer, you can issue Lumens to your staffs as payments. So you can now start thinking of Lumens not just as what you use for transaction fees, what you use for renting and all of that. You can now start thinking about it in a different sense and as even a source of payment. So this can literally be categorized again under uses of the XLM, which is the Lumen token. Transaction fees and base reserves. Stellar requires transaction fees to prevent spam and prioritize transactions. Minimum balances are calculated using base reserves. Why exactly? I'm sure, I think I spoke about this once, but I didn't go deep into it. Why exactly do you need to pay for transaction fees in the first place? Why do I need to pay for these fees called gas? Why do I need to pay for gas? Well, this is because if you think about it logically, you can think of the blockchain as a world state computer. That's because all of the nodes all around the world that comes together to form this chain literally can be called just one computer. Because at the end of the day, the block one on node A, on node B, on node C are literally the same blocks. So the latest block on all of these nodes are literally the same block. So this means that everything that is added to each node is added to every node. So why am I talking about this? I'm talking about this because imagine someone sent a transaction that loops forever. So imagine this transaction was picked up by the validator, and then the validator adds it, and this computation keeps running. What then happens? This means that the network would stop for every other person. And this means that nothing will be added until that computation is completed all over. So you can imagine where the whole system is waiting for just one person due to the transaction is sent that involves a function that loops forever. This could literally pick up and eat up the computing resource for the all participants of the node. So all those who are running that particular client, imagine all of them having to wait just for that loop to continue. Imagine it is then an infinite loop. Now, when I'm talking about loop, it's all right if you are not yet a developer. We'll be seeing what loops are when we start learning about trust. But in your mind, it's just a recursive function, running a recursive function. That's just an example of what you can think of it. Running a recursive function that keeps running. So imagine you have this and it sends to all of the different nodes all around the world. This becomes a problem as no other person can send transactions to the blockchain. And for this very reason, gas comes into place. So before any transaction is sent, the total resource needed to send that transaction is computed. And that total resource is then converted to the amount of fees needed to send that transaction. So for every single transaction you are sending, the computation needed for that transaction is computed, and then it's converted into fees that you pay for that transaction. So imagine someone that wants to run an infinite loop. Now, an infinite loop will take in infinite computation. So that means the person have to have infinite gas fee. So automatically, the system blocks him out and is unable to run this. So this is more like a mechanism to avoid like a stoppage on the network. Bad actors could also use this to run what we call DDoS attacks. And this kind of attacks, thanks to the gas fee, it is not possible to run it on the network because you have to pay for the fees. So this is literally one of the important reasons where gas fee or why gas fee is incorporated into the network. Now I'll stop sharing my screen and I'll start sharing the Stellar documentation to talk more about this. Like I made mention of, I'll be showing what the fee looks like, transaction fee. So let me share this. Now, this is the Stellar official documentation. And like I made mention of, I like it when I show you how to, get resources, because at the end of the day, we cannot completely teach every single thing that is needed to be taught. So in your own time, when you are free, you can definitely go into using the Stellar documentation to understand some other points that might not have been spoken of in the class. And that's why I'm using the documentation to explain this part the more. Also, when you become a developer, for those who are not developers, you might definitely need at a point in time to go through documentations to understand some things about whatever you are building. So this is more like a review as to why documentation is literally important. So the fees and the resource limits and metering. So this particular section on the documentation literally talks about the fees, and it makes it clear that the resource fee only applies to smart contract transactions. This means that the amount that is based on the transaction's resource consumed for the state of the network storage, which I have spoken about, this particular resource fee is incurred for it. What then is the inclusive fee? Is the maximum amount the submitter is willing to pay for the transaction to be included in the ledger. So this means that inclusion fee is, okay, I want my transaction to be picked. So now here's the idea of what happens. So when you send a transaction, this transaction is sent to a pool. The pool includes different transactions that are sent there. So you then add a fee to the pool transaction and be like, okay, this fee I'm putting is the fee I want to submit so that my own transaction can be picked and it can then be added to the block. Now, if you think about it critically and clearly, the time taken for you to send the transaction, for the transaction to be in the pool, for the validator to pick that transaction from the pool and then validate it and add it to the ledger, all of these things take a little time. That's, in fact, one of the reasons why we said the blockchain is a little slow compared to other systems that I've made mention of, like Visa and all. Then that's where we started talking about the layer 2 infrastructures that literally help with this. But just to come back to what we are talking about, this inclusion fee, that is literally what it does. That is literally what it is. And you can compare it to the resource fee, where it is literally the amount of transaction resource you are trying to compute. This specifically applies to smart contracts because when you are talking about storage rent fee, this literally talks about, from what I've spoken from last class, it literally talks about whether your smart contract, you want it to be a temporary or a permanent storage. Now, look at the calculation for, okay. Okay.
Yeah, sorry, Mr. Ayo.
Okay.
I would like to ask you, is this fee is it fixed the ratio, or is depend on the maybe the node which validate your transaction? I mean, it's your
Now,
smart contract.
we've spoken about two types of fees. We've spoken about the resource fee and the inclusion fee. So which fee are you talking about?
I'm asking about the inclusion fee.
So can you ask your question again about the inclusion fee?
I'm asking if it is having the fixed ratio, or
Okay.
it is depending on the resourcing on the network.
Now, that's a very good question. So now, for the inclusion fee, it is not fixed. This is because, as a person, there is something we call arbitrage in fact, I don't know if you've heard of the word arbitrage. Arbitrage is literally a situation whereby you try to leverage on different market prices, and then trying to leverage on these two different market prices, you try to imagine on I'll use, what can I use for example? I'll use a simple example. What country are you from, and what native currency is being sold in your country?
I'm from Tanzania. We are using TZS.
Good.
TZS dollars.
Now, for your currency, TZS, now imagine you have Bank A. Bank A sells one TZS for $2. Now, Bank B sells one TZS for $3. You then saw this opportunity as an opportunity to make money. So you went to Bank A and then you bought the TZS for $2, and you went to Bank B and you sold it for $3. You have made $1. Now that is literally what arbitrage is. So arbitrage happens in the blockchain. Now, in a situation whereby this kind of situation happens, where now when we are talking about this, we are talking about DeFi. this particular situation, you then want to run a transaction whereby you notice that on this particular DEX, the price of this token is lower, and then on this DEX, the price of the token is high. So many people are looking for this opportunity to, perform this arbitrage. You then want to send your own transaction for your own to be picked up first, so that you can get the reward from arbitraging, that's selling here and buying there and getting your profit. For this reason, you might want the validator to pick up your transaction faster. And in this case, your inclusion fee, you could increase it. And then when the validator sees it, it picks it up, and then the transaction is then what? Is then validated quickly. So for this reason, it has a base, but it doesn't have a fixed price that you can use for the inclusion fee. So does that make sense? Shaliga? Okay, great.
Yes,
Now,
yes. Thank you.
yeah. Now moving on. Talking about the resource fee. So now when you are deploying your smart contract, you have to understand this. You are paying for the resource fee and the inclusion fee. Why? This is because, first of all, you are paying for the storage you are using. Then second of all, you sending that transaction that is deploying a smart contract is actually sending a transaction to the chain. So you are paying for the storage your smart contract will be using. You are also paying for your transaction to be picked up. And what's the transaction? Creating new smart contracts. So that is literally deploying your smart contract. You are paying for that transaction too. So in this case, the transaction fee for that would then be the resource fee, which is for the storage, that's the Soroban data dot resource fee plus the inclusion fee. So this two is what you pay. Imagine you want to send a transaction that includes deploying your smart contract. So there are certain things your resource fee could depend on. Now, what are those things? First, the instructions, the number of compute CPU instructions the transaction use, metered by the host environment. What does this mean? This means how many functions are you writing when it comes to the smart contract you are building, and inside of this smart contract, what are the things, your function, how large is it? What are the things the function is doing? Is it adding this to this, minusing it from this, storing it from into this, calling an external contract, interacting with another contract, then storing into storage? How large is the computation for the transaction that it uses? These instructions, it falls under how much the resource fee would be. Another thing is the ledger entering access. So whether you are reading or you are writing, any single ledger entry, you have to pay. And for this reason, it's different. I know if you are coming from the EVM background, you'll be like, you can make so many read calls without having to pay. But in this case, it's actually different. So there are fees you pay for any kind of transaction you are trying to make, especially when it's either reading or writing transaction, you have to pay for it. Ledger, the number of bytes written from or written to the ledger. So we could actually talk about this byte as interacting with the contracts. So how many times are you reading? How large is the things you are sending to the contract? How small is it? How large is what you are reading? How large is what you are sending to the contract? All of this literally affects the resource fee. Another one is the transaction size. The size of the transaction submitted to the network in bytes. So all of this is actually closely related, but all of this literally affects how much resource fee you are meant to pay. Another interesting one is the event and the return value size. So imagine you are writing a function, and every single time that function is called, you want an event to be emitted. So the size of the event that is being emitted from that function every single time it is called, you have to pay for it. In this case, the resource fee would also be dependent on that. What about return value size? This means after you finish writing your function, then you include return whatever. So whatever you are returning, the size of what you are returning also affects your resource fee. The last one we'll be talking about is the ledger space rent. So the ledger space rent is the one we have spoken about extensively at the end of yesterday's class. So the payment for the ledger entry, the TTL extension, and the rent for increasing the ledger entry size. So after you've paid for your storage, you could also increase it when you notice that, okay, because actually you can definitely query how long you want your smart contract. I'm sorry. Sorry. You can literally query how long you want your smart contract to live on the network. So when you notice that, okay, it's getting to the end of the rent period, you can literally pay more for it. And then once you pay more, it literally adds to, you know, your the lifetime of your smart contract living on the ledger. Why are we talking about all of these things? Why are we specifically pushing or pointing out to this simple, or we might find it as useless information? Why are we talking about it intently? This is because as a smart contract developer, one of the important things you want to put in art is that you want your application to be friendly to your users. What do I mean by this? This means that for every single time your user calls a particular function from your smart contract, you don't want the fees to be too heavy on the users. You want it that when your users call your smart contract, they are paying very less fees. Why is this? Because as a developer, if you are probably the owner of a company and you're literally having users use your product, and users are complaining that I want to perform this transaction, how much I am trying to send through this transaction, the fee is even greater than how much I'm trying to send. I would rather want to use a different product that would allow me pay lesser fees. And all of these fees come into place when you are writing your smart contracts. So it is important that you take note of how you optimize your smart contract, starting from the return size of your data. Should you return a value? If it's not necessary, don't return it. Should you emit an event? Why are you emitting this event? Take into play why you are emitting it. Should you always try to make a read or a write to the storage at every interval? Can you make a read to the storage and then store it as a local variable to help your computation even faster and to help your computation take lesser grass? All of these things are what you start thinking of as to your development patterns. When you start thinking of the architecture behind whatever DApp you are trying to build, you start thinking of how to optimize your application so that your users are happy to use your application. Because trust me, if I have product A and product B that are literally having the same product, but then for product A, when I call a particular function from product A, let's use an example of a DEX. Imagine we have DEX A and DEX B. Now for DEX A, if I call the swap function, for the swap function, it is always taking about 10 lumens for the gas fee. But for DEX B, it is always taking about 1 lumen for the gas fee whenever I'm trying to swap. You as a user, would you want to use DEX A that is taking in about 10 lumens for the swap? Or would you rather want to use DEX A that takes 1 lumen for the swap? This is what you have to start thinking of as a developer. It's not just all about the code you are trying to write. It's all about also understanding how your users that are calling these functions would also think when it comes to your application. So that is more about fee. Refundable and non-refundable fee. Before I proceed from this particular point, I would like to see if there's anyone that have any questions up to this particular point. Divine, please. You can unmute and speak.
Okay. I wanted. Okay. I wanted to ask. You said for every interaction we pay fee. Does it mean like when a user wants to interact with a smart contract, like maybe wants to connect his wallet or sign the transaction, he has to pay gas fee for that? On the
Yes.
Stellar chain.
Yes, he has to pay. You are not now. Listen. When you yourself, as a developer, you are done writing your smart contract, you are going to send this transaction. That is, you are going to deploy this smart contract to the chain. You understand? Now, when you deploy this smart contract to the chain, in the process of deploying it, you are the one that is paying for the transaction fee at that time. You are the one also paying for the resource fee. The resource fee is literally the storage, how long you want your smart contract to live on the chain. You are the one paying for it. Now, at the end of the day, when you now finish building, you've deployed, you've created, okay, I'll come to you Sunday. You've created a user interface. Now your users are calling your smart contract. For every single transaction your users make, they are also going to pay fees for it. And that's exactly why whenever you are, I made example of a DEX, that's a decentralized exchange. For every transaction you make there, you have to pay for the gas fee. The person that deployed the contract is not the one that will pay that one for you. Now, for that kind of transaction, we the blockchain has advanced so much, and new concepts like account abstraction is coming into place, where you don't have to pay for the gas fee yourself. You can literally use a paymaster through account abstraction to literally pay for the gas fee for this person. But all of that aside, at the end of the day, what happens under the hood is that gas fee is still paid for every single transaction. Does that answer your question, Divine?
Yes.
Okay. Someone else hand is up. Sunday, you can go ahead with your question.
Okay, good evening.
Good evening.
First off, I want to confirm something.
Okay.
So in terms of paying for every transaction, you also mean that okay, say it's a DeFi now, yeah, and the DeFi operates on a wallet inside of the application, and I want to check, say, my balance inside of that wallet. Does that also mean I pay gas fee?
Now, that is different. Remember, we were talking about the Horizon API. The Horizon API gives you access to check something like that. The Horizon API gives you access to check something like your account balance. And in this particular case, you really don't have to pay for that. So does that answer your question? But then if you're actually querying a smart contract, in this case, you have to pay for the gas.
Okay. Yeah. I just wanted to clarify that. And then the actual question is, you said that so basically your smart contract to stay on the blockchain is like a subscription, yeah. So once it starts to elapse, you have to like renew that subscription. I don't understand that concept because it does not exist on the Ethereum on the EVM.
Yes, very correct. Very correct. You see, when I started talking about rent, I don't know, Sunday, were you in yesterday's class?
Unfortunately, I wasn't.
That is a problem. While I made mention, I would want you to also
Okay.
go back.
If you talked about it in yesterday's class, what I'll do is I'll just go watch your previous video then instead of having to
Exactly,
have you.
exactly. Let's do that. Let's do that. Thank you very much. Let's do that. So I'll stop sharing my screen and I'll start sharing my slide back, as we've used that to talk about the fees. Talking about the test net and the future net best practice. Best practice for using the test net and future net effectively includes understanding their limitation and preparing for reset. You see, we made mention that these environments are test environments. And what happens in test environment is that the developers at the Stellar at the Stellar Foundation are not sleeping. They are working. And working means they are trying to improve the system at every single time. And they are thinking of new upgrades that can be added to this system. And some upgrades might include the system, that is the network, being wiped out. I'm not talking about the main net now. We are talking about the test net and future net. So you have to be updated about all of these things. You have to understand when you need to use the test net and when you need to use the future nets. Understand the ideal scenario for using all of this network. I'll give an example of a situation where someone might use testnet, and in other sense, it might want to use the future net. Now look at this scenario. Imagine you as a company, for the blockchain team, you guys are being told to have different environment. I think I spoke about the different environment, understanding the dev environment, the staging environment, and then the production environment. Imagine you are using the test net for the dev environment, and then you now choose to use the future net for your staging environment. Would you say that makes sense? Absolutely not. Why would you say not? This is because the future net is not even as stable as the test net. And this is because the future net literally is where so many experiments are being done. So you know what is moving from dev to the staging environment is what is deemed worthy to go into production. And it is a stage or a point where by the application is being tested whether it is deemed to go into production. Now imagine you are the CEO of the company and then you want to pitch to investors, or in fact you are presenting it for an hackathon, and then you notice that everything is wiped out. The UI you created can no longer interact with the smart contract because everything has been wiped out. In this case, you were using FutureNet. Would that have been a wise situation to do such a thing? The answer is no. So that's why it's important to understand where you need to use the FutureNet, the testnet, and the mainnet. Limitations and considerations for developers. Key consideration to keep in mind while developing on this network is literally what I have made mention of. Data management. Tips for managing data and configuration to minimize disruption during reset. Well, when you are active in the Discord, whenever there is a major changes or anything, there is literally a channel dedicated for that. So if you are active in the channel, then you won't have any problem basically. But at the end of the day, most of these changes really happens in the testnet. So once you are able to understand when you are using your testnet for whatever you are testing, understanding that the situation or scenario should be different from when you are using the future net, then you are good to go, because the testnet is rarely configured or reset. That happens more often in the future net than the testnet. Collaboration too. Collaboration with other developers to share insight and solutions. Why did I put collaboration here? This is because one of the best practice as a developer is having developers, literally. Having developers. Informations are easily heard by developers that are useful to you. And so collaborate with other developers to get this information whenever you are building. Moving to production. Now, we are talking about moving to production. Why are we even talking about moving to production? This is because transitioning from testnet or future net to mainnet involves changing the network faces and ensuring database reinitialization. What are we talking about? This means that there are various steps that we must check before we move to production. What are these things? Some of these things would include auditing of the contract. Has the contract been completely audited before it's moved to production? Another thing is how optimized is the contract now before it is moved to production. Remember, everything that is going to production is on the mainnet because the mainnet is where the real asset is being backed. And trust me, you don't want to keep deploying to mainnet so often because for every deployment you make, you are literally paying for it. And we've gone through today's class explaining how much fees you can pay, especially when you are deploying a smart contract. It's completely different when you are just interacting with the smart contract. But deploying, you have to pay for the transaction fee to send it to the transaction that is deploying the smart contract. And you also have to pay for the rent, that is how long the smart contract will be using. So that's literally it. Thank you very much, everyone. We have a minute left, and it's 3 minutes. We would want to use it as a time for discussion and for questions. So are there any questions, discussions, or something you would like to add to what we have just discussed in today's class? Okay, Divine. Okay, then.
Okay. I was kind of curious. Like when a smart contract is deployed, like are there any checks to know if the code is like maybe has something that is malicious in it or that will affect anything? And is it possible for the smart contracts to affect the blockchain?
Okay, good. Good question. So now I'll start with answering that part that says, is it possible to have something that checks for if the smart contract itself is malicious? Now, to understand that, you have to understand that the whole system as a whole, the Stellar Core, has a place where the smart contract is being stored. You are going to learn that in future class. You are going to learn that. So whatever is happening in this smart contract is restricted to that smart contract, unless the smart contract is interacting with another smart contract. But what is happening in the smart contract cannot directly affect the security of the chain. This is because one of the biggest reasons for this is the gas fee mechanism that was placed in check for this. So now, when we now talk about checking of the smart contract before it is being deployed, now think about it. Since it's not affecting the network, you as a whole, as the person deploying the smart contract, is responsible for all the vulnerabilities happening to the smart contract. Now, if the smart contract is a smart contract that has finance backing, that is, for example, is a smart contract that holds people's money, whether it's staking, whether it is a DEX, whatever smart contract it is, you have to audit that smart contract. So you literally have to take it to smart contract auditors to audit it. And before you take it to them, you also have to use certain tools to audit the smart contract. The tool will just literally go through the smart contract, and it will just point out general or relatable vulnerabilities that it sees in the smart contract. Then you can literally correct this smart contract, because these vulnerabilities in this smart contract, it is the smart contract, it affects itself. So that's literally it. And the truth is, once you have deployed the smart contract, you have deployed it. Remember, we made mention that it's an irreversible action. And that's part of what we are talking about, the blockchain. So once you've added something to it, it's immutable. It can't be changed. So that's literally it, unless you deploy a new smart contract before it. Then you added one more question to the question, Divine. What was it?
No, you've answered everything. You've answered everything. You've answered what?
Okay. So are you fine with the answer?
Yes, yes.
Okay. So Ben, can we hear your question quickly, please?
Yeah, okay, are you? Are you just a quick background of me? I joined this course because I'm a blockchain enthusiast and I would like to learn, obviously. It's just that right now I can notice that I'm a bit behind, and if you could advise me, how can I catch up? Like from this week ish, I've been learning a lot of words that I'm not very familiar with, and I don't really understand, but I have the knowledge of what we are speaking about. What can you advise me to like to do, like going forward with this course? Because I'm interested. I'm willing to do whatever it takes just to understand and be on par with everybody. Because I can notice right now I'm behind in
Okay.
terms of understanding.
Okay. So here's the thing. The beautiful thing about these classes is that all of the classes is recorded. So now, at your free time, you can literally go back and watch these classes all over again. The beautiful thing about this whole learning system is that we have a channel where you can literally ask questions. Now, if you ask questions in the channel, I could even be the one to answer your question in some situations. But in some other situations, I might not even be the one that would answer your question. Other people could answer your own question because everyone is learning together. And that's, in fact, one of the things happening. So I want you to stick with the class. Also, at your own leisure, try to go through the stellar documentation, and it would literally help with your growth. And for missed classes, you can rewatch the video, you can rewatch it over and over and over and over again. So that would really help.
Okay, thank you.
Yes. Then Sunday, I mean. So that will be the last question we'll
Okay.
take Sunday.
Okay, no problem, boss. Yeah, I want to understand something. Something has been confusing me. The concept of the test net and the feature net. I want to understand the use case of the feature net. Like being that we already have the test net, and the test net is supposed to cover for development process and obviously testing cases and the rest. Is it that the feature net, obviously, it will still require a faucet. So, what's the use case of the features chain? I be net, whatever.
Okay. So were you in the class where we were talking about the future net?
Yes, I think I was. I think I was.
Okay. Now, the future net in a simple sense is literally um, the network where core implementation of the chain itself is being implemented. Now, I'll give you an example of something or a scenario where you as a smart contract developer might need the future net. Now, imagine there is a new development from the Stellar core that involves account abstraction being incorporated inside of the core of the network. Now, with this, you can now use network calls, certain transaction calls into the network itself to leverage on this account abstraction. Now, before that particular feature is being pushed to mainnet, you as a developer, imagine you are working on a product and you are the one, creating the paymaster, creating the account abstraction contract, you are doing everything. But then you add that, okay, this has been incorporated into the core of the chain itself. And this is available on the future net. So in this case, you can then experiment working with your smart contracts with this incorporated account abstraction on the chain with your smart contracts. So you experiment it and then you notice that, okay, it works and it's better. So that is a particular case where you as a developer could come into place to use the future net.
Okay, I get it now. I get it. I get it. So basically, the feature net allows for to implement or interact with concepts that are still under improvement, basically.
Exactly, literally. That's why it's future net. Things that are coming in the future that are not yet in the mainnet. Yeah, so that's literally it. Does anyone
Okay.
also have any more questions? So if not, this would be the end of our class for today. And as usual, I'm not happy that some people already left. You could gain from the question that other people asked. You could literally gain. I'm not happy that some people left already. Anyways,
Boss, when are we expecting our assignments?
exactly. Between today and tomorrow, the assignments for this week will be sent. Between today and tomorrow. So I want you to pass this information to others that have left the call before the call is over. So the assignment will be sent to the coding class channel between today and tomorrow. Thank you very much, everyone. I'll stop the recording now. And I really appreciate you meeting up